Hey guys, this is Princey. I'm going to be explaining a topic from math in this video. The topic is joint probability distribution for two discrete random variables. The first we have introduction to joint probability distribution, defining key concepts and their significance. Definition: joint probability distribution quantifies the probability of multiple discrete random variables occurring simultaneously, capturing the relationships between them in a unified framework. Importance in statistics: it serves as a foundational concept in statistics and data analysis, enabling the understanding of independencies and the structure of multivariate distributions. Overview of discrete random variables. Discrete random variables represent countable outcomes such as the number of successes in a series of independent trials and are essential for probabilistic modeling. We have understanding discrete random variables, foundational concepts and applications. Definition of discrete random variables. Discrete random variables takes on distinct and separate values such as integers representing measurable outcomes of random process. Examples: common example including the number of heads in coin tosses, the result of rolling a dice, or the count of items sold by a store. Probability mass function (PMF). The probability mass function gives a probability that a discrete random variable equals a specific value, serving as the foundation for constructing joint distribution and analyzing aggregated behaviors. We have joint probability distribution explained, delving into the mechanics of joint distribution. Definition: joint probability distribution describes the likelihood of two or more discrete random variables that occur in tandem, providing insights into their shared behavior. Joint PMF. The joint PMF indicates the probability of independent and dependent relationship between variables, facilitating understanding the complex statistical interdependencies. Visualization of joint distribution. Visual tools such as heat maps enable an intuition grasp of joint distribution, aiding in the comprehension of probabilistic relationship between random variables. Next we have expectation of joint random variables, foundational concepts and mathematical methods. Definition of expectations: the expectations of joint random variables in the weighted average of all possible values, considering their probabilities, reflecting the central tendency of the distribution. Calculation methods such as the law of total expectations and iterated expectations help calculate the expected values for joint distribution, facilitating complex analysis. Properties of expectation. Properties like linearity ensures that expectations can be computed for sums of variables, enabling simplified calculations in joint distribution. And next we have covariance of joint random variables, understanding relationships and dependencies. Definition of covariances measures the degree to which two random variables change together if they tend to increase or decrease together. Covariance is positive, indicating a direct relationship. Calculation of covariance is computed using the expected values of the products of deviations from their means, revealing insights into the relational dynamics within joint distributions. Interpretation of covariance helps in understanding the nature of relationship, whether strong, weak, positive, or negative, which informs decision making, imperative analysis. And next we have Here is correlation coefficient, understanding the measure of relationships. Definition of correlation. The correlation coefficient quantifies the strength and direction of the relationship between two random variables, standardizing the measure to account for variability scales. Difference between covariance and correlation. While covariance indicates the direction of the relationship, correlation standardizes this measure, providing a dimensionless value that facilitates comparisons across varied databases or data sets. A calculation of correlation coefficients. The correlation is calculated as a normalized covariance, offering insights into relationships that are more interpretable than covariance alone. And next we have properties of expectation, covariance, and correlation. Fundamental principles that govern statistical measures. Linearity of expectations. The expectation value possesses a linearity property, allowing sums of expected values to facilitate complex computation in joint probability settings. Covariance properties. Properties such as symmetry and bilinearity of covariance provide a deterministic frame for analyzing relational dynamics in variable pairs. Correlation properties. Correlation exhibits boundedness within the range of -1 to 1, ensuring ease of interpretation regarding relationships across database or dataset. Next, we have applications of joint probability distribution where theory meets practice. Real world applications. Joint probability distributions are pivotal in disciplines such as finance, insurance, and healthcare, providing crucial insights for decision makers and data analysts. Statistical modeling. They form the backbone of sophisticated models, including Bayesian networks and macro chain analysis, enabling nuanced prediction and inferential statistics. Risk assessments. These distributions assist in quantifying and mitigating risks through comprehensive evaluations of multiple independent events, crucial for proactive business governance. Now we have the last slide's conclusion and key takeaways. Summary of key points, importance of understanding joint distribution, and final thoughts. Summary of key points. The exploration revealed foundational concepts, applications, and methodologies related to joint probability distributions, affirming their significance in statistics. Importance of understanding joint distributions, grasping the behavior of joint distributions, and vital for accurate statistical inferences, enabling effective decision making in complex scenarios. Final thoughts are ongoing exploration and research into joint distributions will continue to foster understanding and enhance statistical methodologies benefiting various fields. This is the last slide, guys. Thank you for watching.